Hello students. In this class I'll be teaching you about asymptotes. So a straight line is said to be an asymptote of an infinite branch of a curve if as the point some point P on the curve tends to infinity along the branch where if you drop a perpendicular from P onto a line and if the perpendicular distance keeps on reducing along the curve between the curve and the line, it tends to 0, then you call that straight line as an asymptote. Or you can also say it as the curve approaches to one of this straight line and that straight line is called as an asymptote. So there are two types of asymptotes. The first one is asymptote parallel to the coordinate axis and the oblique asymptote. So when you look at in this example, you have the curve y is equal to 1 by x. So at this point here as well as here, the curve approaches to the straight line y-axis and the straight line x-axis here. So here x-axis and y-axis is an asymptote to the curve y is equal to 1 by x. Now we'll go to the next the types of asymptotes. So if you have an asymptote parallel to y-axis, to find the equation of an asymptote is given by this rule. Any asymptote parallel to y-axis are obtained by equating to 0 the real linear factors and the coefficient of the highest power of y in the equation of the curve. So that means you have an algebraic equation of the curve. You take what the highest coefficient of highest power of y and take the coefficient of that and equate it to 0. Then you will get the equation, and that equation will be the equation of an asymptote. The same rule applies for asymptotes parallel to y-axis. So you have a curve here and this is an asymptote parallel to y-axis. Same way, asymptotes parallel to x-axis is obtained by you equate the coefficient of the highest power of x to 0 and then you get the equation of the asymptote parallel to x-axis. If suppose the coefficient of the highest power of y in the equation to the curve is either a constant or has all its linear factors imaginary, then the curve has no asymptotes parallel to y-axis. The same rule applies to x-axis also. So if the coefficient of highest power of x or y is either a constant or imaginary number, then it has no asymptotes parallel to that axis. And this is the oblique asymptote. So if you have a curve here and you have an asymptote. So this is an oblique asymptote which has slope as well as the intercept x or y, x intercept or y intercept. Now let us find the asymptote parallel to the coordinate axis for the following curves. So you have the curve here, the curve equation of the curve is given. Now I'll write this equation as x square into, because I need to equate the highest power of x to 0. For that reason, I am taking x square as common and writing it as y square minus a square is equal to a square y square. Coefficient of highest power of x is y square minus a square and equate this to 0. We get the equation solutions as y is equal to plus or minus a. So y is equal to plus or minus a is an asymptote parallel to x-axis. Now rewriting the equation in the form, now again I rewrite this equation because I need to equate the highest power of y to 0. So when I rewrite it, I can write it in the form x square y square minus a square y square. I bring a square y square to the left hand side and a square x square to the RHS. So writing like this, I equate the highest power of y. Coefficient of highest power of y is x square minus a square, that is equal to 0. That is nothing but x is equal to plus or minus a, and this is the asymptotes parallel to y-axis. So we have asymptotes parallel to the coordinate axis are x is equal to plus or minus a and y is equal to plus or minus a. Similarly, let us look at the second problem. We have this equation. The given equation is this, or I bring all the terms to one side so I can equate it to 0. Writing it like this, the equating the coefficient of highest power of x to 0, we get coefficient of highest power of x is nothing but x square. So coefficient of that will be minus of y plus 1 is equal to 0, or y is equal to minus 1 is an asymptote parallel to x-axis. Similarly, we equate the highest coefficient of highest power of y to 0. So we have here the coefficient of highest power of y is nothing but y cube, and the coefficient of that is 1. Since it is a constant, you don't have any asymptotes parallel to y axis. This is the third problem, and this is similar to the first one. To do it yourself. Now we determine this is the rule only if you have to find the equation of the asymptotes parallel to x-axis or y-axis. So in general, if you have to find the oblique asymptotes, then you have to follow this rule. So you have the equation of the curve to be of nth degree equation representing the given curve. The first step is arrange the terms in LHS of the polynomial equation to the curve into groups of homogeneous expressions of the same degree in this form. That means, say you have nth degree equation. Say I take third degree equation. If suppose you have a third degree equation, you will have terms containing x cube, y cube, x square, y, all these things. So whenever you have an x square y, you need to add the powers of both x as well as y. So you get the degree as 3. So you combine those expressions which have the same degree. So if I have x cube, y cube, x square, y, all these comes under h3. You combine that into one part, and that you express it as hn. So here hn means you combining all those terms of the equation having nth degree. Now hn minus 1 is you take all these terms having n minus 1 term, n minus 1 degree. So in case if you have n to be 3, then all third degree terms I will combine into h3. Two second degree terms I will combine to h2. 1 degree terms I combine to h1, and the constants I keep it as h0. So this is how you segregate the expression. So where hn consists of terms of degree n. So that expression I'm writing it in this form. The second step is you need to put x is equal to 1 and y is equal to m in the left side of the equation written in step 1. So in this one, you substitute x is equal to 1 and y is equal to m. So then the equation takes the form phi n of m. So this hn will be transformed to phi n of m. Hn minus 1 is nothing but phi n minus 1 of m, and so on. All these terms, instead of x and y, will be in terms of only m. Now the third step is you equate phi n of m is equal to 0, and from this you will get the slope of the asymptote. So slope of the asymptotes is nothing but I'll write it as m1, m2, or so on. So let m1, m2 be non-repeated values of m. So in the step 4, use the formula c is equal to, now whenever you have to find the equation of the straight line, equation of the straight line is given by y is equal to mx plus c. So from step 3, we have found out what is the slope. So m is known. Now we need to find out what is the intercept. So to find the intercept, so we write it as c is equal to minus phi n minus 1 of m divided by phi n dash of m for non-repeated values of m, which gives intercept c1, c2, and so on. Then the asymptotes corresponding to them are, so from this equation we have got what is c1 and c2. So we can write y is equal to m1x plus c1, y is equal to m2x plus c2. If suppose phi n dash of m is equal to 0 and phi n minus 1 of m not equal to 0, then there exists no asymptotes for that particular value of m. If suppose phi n of m is equal to 0 has a repeated root twice, in this case you had a non-repeated root. When you have a non-repeated root, you use this formula, c is equal to minus phi n minus 1 of m by phi n dash of m. If suppose the root is repeated twice, then you have to use this formula, that is c square by 2 into phi n double dash of m plus c into phi n minus 1 dash of m plus phi n minus 2 of m is equal to 0 to find the corresponding values of c. In this case, you get two parallel asymptotes. So these are the 5 steps which you have to remember to find the equation of the asymptote, which is an oblique asymptote. So these are some things which you have to remember while solving the problems based on asymptotes. Total number of asymptotes, real, coincident, or imaginary, cannot exceed the degree of the curve. Suppose you have equation of the curve to be 3, so the degree of the equation is 3, then the total number of asymptotes will be at the maximum 3 and not more than that. While determining the asymptotes of rational algebraic curve, you need to first find out the asymptotes parallel to coordinate axis and then the oblique asymptotes. So it is not necessary that whenever a curve is tending to infinity, all those curves will have an asymptote. For example, parabola extends to infinity, but it has no asymptote. Problems. Let us look at the problems on asymptotes here. First problem, find the asymptotes of this curve. The first step was you need to arrange the terms having same degree. So for that, what I do is there. Okay, before that, you need to first find out whether there are asymptotes parallel to coordinate axis. So the highest power of x is 3. Coefficient of highest power of x is 2, which is a constant. So you'd have no asymptotes parallel to x-axis. Similarly, coefficient of highest power of y is 3. Coefficient is 1, so it is a constant. So you have no asymptotes parallel to y-axis. Hence, there are no asymptotes parallel to the coordinate axis. Now, let us write the equation in the form. Since the degree of the equation is 3, I'll write it in the form of h3 plus h2 plus h1 plus h0 is equal to 0. So, h3 is all those terms having the degree to be 3. So this will be 2x cube minus x square y minus 2xy square plus y cube minus, now I'll write h2 term that is of degree 2. Degree 2 terms will be minus 4x square plus 8xy minus degree 1 term is just minus 4x and the constant is written as h0, so that is nothing but 1. Now we put x is equal to 1 and y is equal to m in the equation. So we get, when you substitute x is equal to 1 and y is equal to m, here we get this as m cube minus 2m square minus m plus 2 minus 4 plus 8m minus 4 plus 1. You're substituting x is equal to 1 and y is equal to m. So from this we have phi3 of m. Phi3 of m is nothing but corresponding to h3. So that will be m cube minus 2m square minus m plus 2. Next, phi2 of m is degree 2. So you have substituted in this x is equal to 1 and y is equal to m. So you will get it as minus 4 plus 8m. And phi1 is degree 1. So phi1 of m is nothing but just minus 4. And phi naught of m is constant you take, and that is equal to 1. Now to find what is m, you equate phi3 of m to 0. So to find the slopes, we equate phi3 of m to 0. Solving this cubic equation, we get the values of m to be equal to 1, minus 1 and 2. You can use this method or you can also use the synthetic division uh, to find out the solutions of the cubic equation. So you get the solutions as you get 3 values for m, and for all these 3 values of m, you need to find out what is the intercept. So to obtain c, we use the formula c is equal to minus phi2 of m divided by phi3 dash of m. So phi2 of m is known, minus 4 plus 8m divided by phi3 dash. You differentiate this with respect to m. So you will get this as 3m square minus 4m minus 1. So it is 3m square minus 4m minus 1. So put m is equal to 1. Corresponding to that m, you get c value to be equal to 2. When m is equal to minus 1, you get c is equal to 2. When m is equal to 2, you get c is equal to minus 4. So put m values, you will get c values. Hence the asymptotes are y is equal to mx, it is of the form y is equal to mx plus c. So it is x plus 2. Next y is equal to minus x plus 2. Then y is equal to 2x minus 4. This is how you find the equation of the asymptotes. Now let us look at one more example. And when you see here, there are three asymptotes, and the equation, the degree of this equation is also 3. So you will have three asymptotes at the most, maximum three asymptotes. Next one, you take the equation of the curve. Now first we need to check the asymptotes parallel to the coordinate axis. For that, the highest power of x is 3. So coefficient of x cube is 1. So since it's a constant, there is no asymptote parallel to x-axis. Now highest power of y is y square, and coefficient of y square is x. So you equate that to 0. So x is equal to 0 is an asymptote parallel to y-axis. So one asymptote is already known. Now you need to find out two more asymptotes because the degree is only 3. So let the equation be written in the form of h3 plus h2 plus h1 plus h0 is equal to 0. So h3 is, take all the terms which has degree 3. So that becomes x cube plus 2x square y plus xy square minus h2 is x square minus xy, and h1, there is no 1 degree term, so h1 is 0, and h0 is a constant term, so h0 is equal to 2. Now in this case, you put x is equal to 1 and y is equal to m. So when you substitute x is equal to 1 and y is equal to m, you will get this as 1 plus 2m plus m square minus 1 minus m plus 2 is equal to 0. So looking at into these two equations, you can find out what is phi3 of m. So phi3 of m is equal to m square plus 2m plus 1. Phi2 of m, that is degree 2 equation, substituting x is equal to 1 and y is equal to m, you get minus 1 minus m. Phi1 of m is equal to 0 because there is no 1 degree term, and phi0 of m is equal to 2. You consider only the constants. Now to find the slope of the asymptote, we need to equate phi3 of m to 0. So equate it to 0, you will get this as m is equal to minus 1 comma minus 1. So we have this formula only when the roots are not repeated. Suppose the roots are repeated, then you have to use step 5, this formula. Since the root is repeated, to find c, we use this formula. So c square by 2 phi3 double dash of m plus c into phi2 dash of m plus phi1 of m is equal to 0. So c square by 2 into phi3 double dash. This is phi3 double dash. Twice if you differentiate, you will get it as 2 plus c into phi2 dash. Phi2 dash is nothing but just minus 1 plus phi1. Phi1 is itself 0. So substitute it as 0. After simplifying, you will get it as c square minus c is equal to 0, or c is equal to c into c minus 1 is equal to 0. This implies c is equal to 0, comma c is equal to 1. Therefore, the asymptotes corresponding to m, is equal to minus 1. And for this slope, we have the equation of the asymptotes to be y is equal to minus x and y is equal to minus x plus 1. Thus, the asymptotes of the given curve are x is equal to 0, x plus y is equal to 0, and x plus y minus 1 is equal to 0. So you have one asymptote parallel to the coordinate axis and two asymptotes which are oblique. Thank you. And yeah, you can solve these two problems as a homework.